Okay, so we're gonna take a look at Newton's cradle here. And this is gonna do, or kind of visually show Newton's third law. So basically, the idea of for every action there's an equal and opposite reaction. So if you take a look at this, and you guys have seen these, they've been sitting on that counter behind my desk area all year long. Go ahead and close up your screens. We don't need those anymore. Good. So we said that for every action there's an equal and opposite reaction. All of these spheres have the exact same mass. So if I take one of these and I release it, what would you expect to happen? You expect one to come out on this side? Okay, so I put one in, we would expect one should come out, right? Exactly what happens. To me, these are always kind of like hypnotic. It's like watching a fire almost. It's kind of like, oh, it's easy to kind of zone out with them. So why doesn't it keep going forever? Because this is not a perpetual motion type situation. Why does it eventually quit clicking, and you'll see it kind of sway together and then eventually totally stop? What's at work?
Because the weight and gravity.
Okay, so we have some forces acting on it. What do you hear? What did you hear? You hear it click, right? Click, 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 click. It does keep getting a little bit quieter and quieter. That click sound is energy. So a little bit of the kinetic energy, which is the energy of motion, is transferring into sound. There's also a touch. As the energy passes from this ball to this ball to this ball and then kicks this one out, that's a transfer of energy. So every time it touches, a little of that energy is transferred into that friction or that contact between the spheres.
But would it matter how high you put it?
Would it matter?
Yeah.
So if I just barely raise it, it pretty much comes out the exact same height, almost, right? If I raise it higher, it pretty much comes out. So like if I go like this, if I raise it about this high, I'm expecting it should probably come really close to hitting my hand. Ooh, it touched a hand. So you can predict how close. Now, all the energy that goes in, we're going to talk next unit, energy cannot be created or destroyed. So all the energy in a system has to stay kind of constant. So it's always going to be just a little bit lower than the initial height was, right? Because some of that is transferring into sound, some of it's transferring into friction. There's actually even a teensy tiny bit that is transferred into thermal energy, which is heat, as those items touch. You know, like how friction produces thermal energy. Even though there's just a small, quick touch, there is just a little bit of energy that is transferred into thermal energy. There's also a little bit of friction between the strings and you know, the where they're attached to the sphere. So there are small little transfers of energy, and so that's why it doesn't continue that kinetic energy, that motion, indefinitely. Eventually, like everything else here on Earth, it's gonna experience frictions. There's even like really small air resistance as it's traveling through the air. Did you just say that?
Yeah.
Look at you go. So yeah, there's slight transfers, and so that's why it's not going to continue moving indefinitely. And this kind of leads us into next unit, where we're going to look at kinetic energy and potential energy. So potential energy is the energy that I'm giving it because I'm increasing its height. Kinetic energy is the energy of motion, so that potential energy transfers to kinetic as it's in motion. And so we'll look at this again next unit as we get to that topic. Now, any suggestions? What happens, do you think, if I release two of them?
The two on the end go.
Two more will go out after that.
So two should go out the other way?
Yeah.
Okay? Right? So if two go in, two have to go out. Two in, two out, two in, two out, two in, two out. Right? Same thing with the height. If I have it really high, which hopefully I don't, sometimes I get a little wild, right? We should expect that it should come out to about the height of my hand over here. And it's pretty close, right? It actually hit my hand, so it messed it up a little bit. Okay? Two in, two out, two in, two out.
What if you do 3 against
Ooh, I don't know, let's try it.
3 will go.
So if I go 3 in, there isn't 3 remaining.
3 will go
I
out.
think it'll mess with
I'll
it.
bet.
Think it'll mess it up, it'll get all wonky.
I bet it
No,
go.
3 can go the other way.
3, so you think the middle one's gonna transfer and join on the out?
Yeah.
Actually, it might. That would make sense.
Okay,
Oh.
whoa, 3 in, so 3 have to come out.
What if you did 4? Oh, 4
You
and
are
1.
really pushing the limit today. Alright, let's try 4. Okay, predictions?
4 are gonna go.
4 will have to go out, so you're telling me that it's gonna go like this?
Yeah.
Do a swap-a-roo?
Do a
Okay,
little swap ring ski.
hold on, let me get that one. Oh.
What about 5?
Yeah, what about
What about 5?
Okay, let's see.
I think 5 will go to the left.
It's
and
gonna
five
get-
will
If
go to the right.
5 go in,
I think 5.
if 5 go in, news their law says 5 should have to come out.
Yup.
That is weird. Okay. What if I do at the same
They're gonna
time
stop.
and I try to keep them about the same
It's
height?
gonna bounce a tiny bit.
No, guaranteed
Okay,
stop.
so Brady's kind of showing like this.
It's just gonna bounce.
Do you think they're gonna just bounce and stop?
I think they're gonna
No,
bounce and
I
stop.
think they're good.
I think they're gonna bounce and stop because it's a balanced force, so nothing's gonna happen.
Is it a balanced force or is
Yeah,
it
'cause if you're-
equal and opposite reaction?
If you're pushing it this and this,
Going opposite.
it's gonna go balance.
Okay, let's see. Let me get it nice and still.
It's gonna stop.
It's bouncing back. No.
Okay, so I'm gonna try to hold them pretty equally.
Do it.
Well, sometimes if I don't have them the right height or I have one like kinked a little, it doesn't. So what if we do 2 and 1?
It's gonna just go that way.
One will bounce
So-
that way, 2 will bounce that way.
Let's see, because if 2 go in, 2 should come out, and if 1 goes in, 1 should come out. So they should be like, I don't think my fingers are coordinated enough to do it, right? Let's see. Swap it.
Yup.
Oh, geez, hold on.
That's what I was thinking.
It's not doing very good. Hold on, maybe I'm a little crooked here.
Because it's uneven.
Maybe. Let's try again. Oops. Yeah, 2 to 1. It,
Because the mass is uneven.
the what's on you? The mass, no, I mean, it shouldn't get bouncy. It's getting a
What
little
if you
bit.
do 4 to 1?
Do 4 to 1?
4 to 1.
4-to-1 ratio.
That's hard to hold. Let me see if I can do
I
it
feel
this
like
way.
Burston can do it.
Okay, so, no. So if we go like this, if we're gonna send 4 in, Newton's law said 4 should go out, right? And if 1's going in, then 1 should come out. So let's see. Ooh. And this is why it's called Newton's cradle, right? Because this is perfectly demonstrating his third law.
And they look like a
Whatever goes
magnet.
in should exactly come out. Any other scenarios, any other tries?
Just a question. What if there wasn't the clinking noise and any other thing? Would it go on forever?
Yes, if there was no friction, no air resistance, no friction between the strings and the spheres, no energy transferred,
If it
To-
still had energy transfer, but it didn't do anything else, would it still go on forever?
yes.
What if you take 2 and 1, but you lift the 2 up way less than you lift the 1 up? Like lift that up and then lift that like way up.
Okay. So one of the things that you're gonna see is that gravitational potential energy is mass times gravity times height. So we're doubling the mass, but we're doubling the height over here. So what do you think's gonna happen?
I have no clue.
No clue? Ooh, I might have to try to my other one. Let me not raise that one as much. Ooh, it's pretty equal because you doubled the mass, but then on this side you doubled the height. So those 2 variables kind of balance each other out. Same thing if I If I do this one. Yeah, and so this one, something's like a little cockeyed. It shouldn't be getting mixed up in the middle. Like, it should be able to kind of go smoothly. It shows what's happening, but it just doesn't, it's like something is off.
Right, top.
It's crooked. Just look a little bit.
Yeah. The
Like it's-
holes look.
They're coming in, yeah. Makes it a little awkward. Okay. All right, so we are just about out of time. If you have any others that you think of later through the day, let me know and we can try them out tomorrow.